Constant light thread cutting command G32. The G32 command is primarily used for cutting constant light straight threads, tapered threads, and vortex threads. The format is G32 IPF. IP represents the endpoint coordinates, and F represents the light in the longitudinal axis direction. Always programmed in radians. This command is very similar to the G01 command you have learned before, with X and Z representing the absolute coordinates of the thread endpoint. U and W represent the incremental coordinate values of the thread endpoint relative to the starting point in incremental programming. F is usually used to set the feed rate, but in the G32 command format, F is set at the thread pitch. Its unit is millimeters every revolution. In other words, there is a fundamental difference between G32 and G01 commands. The G32 thread cutting command allows the tool to move in a straight line while keeping its movement synchronized with the spindle, meaning that for every revolution of the spindle, the tool moves exactly one thread pitch or lead. On the other hand, the G01 command only moves the tool, and the tool's movement is not synchronized with the spindle's rotation, which would result in a threading defect if used for thread cutting. Therefore, it is crucial to distinguish between the use cases of the G01 and G32 commands. The basic G32 thread cutting command can be used to cut cylindrical straight threads and tapered threads. When using G32 for thread cutting, the machine servo system inherently has a lag, which can cause irregularities in thread pitch at the start and end of the thread. Therefore, when programming with G32, the tool's entry length and exit length should be considered. Thus, the intel length of the threaded section being machined should include the entry length, exit length, and the originally specified thread length. When using the G32 command for thread cutting, the following issues need to be noted. The feed rate override is ineffective during thread cutting and is fixed at 100%. If the feed is stopped without stopping the spindle during thread cutting, it will cause a sudden increase in the depth of cut, which is very dangerous. Therefore, feed hold is ineffective during thread cutting. After switching to thread cutting mode, if the feed hold button is pressed during the first non-thread cutting program segment, or if the button is continuously pressed, the tool will immediately stop in the non-thread cutting segment. When performing thread cutting in single program block mode, the tool will stop after executing the non-thread cutting segment. If the operation mode is changed from automatic to manual during a thread cutting program segment similar to point 3, the tool will stop at the beginning of the non-thread cutting segment after a feed hold. However, if the operation mode is switched to another automatic mode, as described in point 4, the non-thread cutting segment in single program block mode, the tool will stop after executing when cutting vortex and tapered threads. Constant surface speed control is applied, and the spindle speed may vary, sometimes making it impossible to maintain the correct thread rate. Therefore, G97 should be specified during thread cutting, and constant surface speed control should not be used. Before thread cutting must not include chamfering or rounding the program segment with the move command. Next, let's practice with an example, as shown in the figure for straight thread turning. The known parameters for straight thread turning are thread pitch P is equal to 2 mm, entry depth delta 1 is equal to 3 mm, exit depth delta 2 is equal to 1.5 mm. If the thread is turned in two passes with a depth of cut F is equal to 0.5 mm per pass. The line with G32 is exactly the one that cuts the thread, meaning that cutting starts from the entry length starting point and continues until the thread length ends at the exit length endpoint. Before this, a G00 line must be added to move the tool to the starting position. When this segment of thread cutting is complete, the tool should retract from the workpiece's threaded surface.